Hello everyone. Today our topic is carpooling sharing system. This is our project regarding the blockchain. And today me 21MIC0192 Tejasv Goyal along with my teammates will be going with this. So these are the outlines, like basically what we'll be introducing the introduction, related works, gaps and problem statement, objectives, existing model, proposed model, and what then the conclusion in the references. So basically, what is the introduction? So what is a carpooling basically? So carpooling is a practice of two or more individuals sharing a single vehicle for commuting or traveling to a common distance, thereby reducing the number of vehicles on the road. So there are the historical origins about that. Like carpooling gained prominence during World War II. Like from World War II it started. Like earlier ride sharing initiatives did back in the 1920s. Impact is a carpooling reduces the traffic congestion and it also reduces the gas emissions. So what is the importance of our application, like what we are making? That is, our importance is to eradicate centralized carpool services that control users' data, to create a blockchain-based system for secure direct rider-driver connection. Basically, we are creating a connection between a rider and driver directly without including any third-party apps. So this includes this enhance the privacy, reliability, and security to disrupt traditional carpooling models, ensuring data protection. Our main aim is to protect the data of the user as well as the driver itself. This streamline carpooling by reviving the intermediaries. Okay.
Okay, so moving on to the related work, we went through certain papers. So one of the papers is design and analysis of a secure decentralized car sharing system using blockchain. So of course, the main methodology adopted here is the blockchain-based decentralized model. So certain features that we would like to highlight or we observed in this paper were obviously decentralization and then data integrity and authentication. So what made it different was the data integrity part, they tried to make it tamper resistant and more reliable. And at the same time, as part of authentication, they tried to make it an anonymous. I mean, they tried to make all the participants anonymous, so no one knew who they were. I mean, it was an anonymous way of pseudo anonymity, we could call it. And of course, this paper had certain challenges. Uh, the author has tried to highlight three main challenges. Uh, the first one being scalability. So, of course, this is a blockchain-based car sharing system. So we don't know how to handle in case. So day by day, the users would increase. So how do we manage and have more number of users? I mean, we'll have to, increase the amount of resources that would be needed for the same. And how do we convince the users to adopt? I mean, the second challenge, user adoption. So users need to trust in the system. So the author felt that how would people understand that the transition from a decentralized system, and how do we educate them about this new blockchain technology? And of course, then the question of cost, that's the third challenge, cost efficiency. So how do we balance the benefits that this system offers along with the high cost that it comes with? I mean, especially when you want to scale it and maintain the integrity and other salient features. So this was about the first paper. Moving on to the next one. So the second paper is basically the blockchain-based car sharing platform, by Ivan and several other authors. So the special part of this paper, or the adopted methodology we could call, is Ethereum smart contract and the Solidity programming language. So it's a pretty famous programming language for this for this technology blockchain. So when we talk about this, they're the salient features. I mean, IPFS. So that's the interplanetary file system. So it's technically a distributed file storage protocol that allows computers all over the world, to store and serve files as part of a giant peer-to-peer network. So that is what they are trying to make best use of. And there are two token types. Of course, it's mentioned here, ERC721 and ERC20, that would actually represent the car assets and and allow you to unlock tokens and reward users. So this way, you're incentivizing the participation of users. So users would be, interested in, using that application. But of course, there were some challenges as well that the author has highlighted. Security and stability. You can see that DDoS attacks. In the sense, will the service be reliable? At the critical moments, if the service fails, then the whole system has flopped or failed. So that was a fail. I mean, that was a important challenge that has been highlighted. How do we make the whole system fault tolerant and stable? Apart from that, how do we enhance the security? Because when we scale it, there's a more probability for data leak, and the pseudonymity may not work anymore. And apart from that, how do we integrate it? The integration with the existing resources. See, we want it to be resource efficient as well, environment friendly as well. So when we scale it, the issue of integrating this blockchain technology and smart contracts with the existing hardware and infrastructure would be a possible challenge. This was a small paper, and that's pretty about it. Moving on to the next one. Here we have the vehicular, IOV. It's an IOV based paper, that is, quote unquote, an efficient, secure, ad hoc vehicular networking architecture, blockchain based. So Sachin Sharma and Kamal Kumar have authored this paper. So they believe in, how do we have an IOV model based on blockchain? So their main motive is, to manage information sharing using the benefits blockchain offers. So that's mentioned over here, security enhancement. So blockchain technology is employed to increase trust, reliability, and security. So how do we figure that out, and how do we maintain privacy? How are the security concerns handled? Those are certain things that this paper has highlighted. And among the drivers, the cars, the auto manufacturers, insurance companies, how do we protect them? I mean, maintaining them anonymous, but at the same time delivering the right information to the required people. So those were certain things that were excellently, covered. But of course, at the counterpart, they immediately faced a challenge of privacy and security. Just as the benefit, it became a challenge, especially when you try to bring in large number of people, or I mean, to scale it at a high sense. So then it was becoming an issue. And of course, the resource allocation, just as we saw in the previous two papers over here as well, they were not able to figure out how to effectively allocate the network resources among the vehicles, so that the complex tasks connectivity is maintained, especially in a dynamic scenario. So that is all about the third paper. And so, in summary, if we want to understand the gaps, that we figured out. So, this is one slide that is trying to cover all the gaps from the at least the three papers that we went through. So these are some general things. So you would have noticed I repeated several things, like, let's say, scalability challenges, privacy preservation, and real world testing. So I'll not be talking about that once again, but let me take something that I did not talk about. Let's say the regulatory compliance. So now in the real world, of course, we'll have to abide by the laws implemented or enforced by the government of that particular country or region. So how do we make a stable or a universal application world in the world, all at the same time complying with every region's law? So that is a major challenge, or a realistic challenge, faced by not only this, but of course here the blockchain applications as well. And of course, whatever we have spoken about is something that works mathematically or technically. So the real world testing would let us know of the possible bugs or errors that we might face. And that is also related to, let's say, the security vulnerabilities. And when I spoke about scalability, again, how much energy would be consumed? I mean, it shouldn't make it energy inefficient. So that is another major concern. And apart from that, trust issues and user adoption. So when people hear the word blockchain, for some it is a new technology, and they're scared. So how do we convince them to trust in the system? So all in all, this was a summary of the three papers. Yeah.
Hello, I'm Aarya Ashok, and I shall be stating the problem statement, the objectives, and the architecture diagram that we have proposed. So the problem statement is that we are planning to develop a blockchain-powered solution for a secure and efficient global peer-to-peer carpooling network. Now let us discuss the objectives of our project. Since we are using blockchain network, we can ensure data privacy, facilitate user authentication, improve payment efficiency using cryptocurrencies, foster trust among users, enable global access as the blockchain is available over the internet, enhance user control, reduce administrative overheads as the blockchain will be distributed and overheads can be avoided, streamline distribute solutions, ensure data integrity, and ensure cross-border compatibility. So this is the methodology that is currently in use. A user books a cab using an app such as Ola or Uber. This app connects to the Carpool API, which in turn helps the app connect to the server, which will access your current location using Mix API's GPS handling capabilities, which will allow you to be connected to nearest drivers, enabling you to be connected to your perfect ride. And now we shall discuss the proposed architecture that we have designed. The smart contract is basically a summary of the core functionalities of our software, like the request car, the retrieve balance, and such features are elaborated and explained in the smart contract. The customer will be able to access all the functionalities related to him through the smart contract. Similarly, the car owners who will be our drivers basically will also be able to connect to all the functionalities related to them through the smart contract. This smart contract in turn is embedded into our blockchain network, which can be accessed through our app. The app is common to both customers and owners, but will have a different UI for both of them based on their functionalities. The app in turn is connected to a storage data warehouse where all the data related to our customers and car owners will be kept securely over the blockchain. Similarly, even payments through the app will be done via cryptocurrencies to ensure safety and privacy. Thank you.
So now I will be explaining technology to be used. The latest technology that will be used for this studies are blockchain technology. Blockchain is at the core of the system, providing a decentralized and immutable ledger to record transaction, verify identities, and manage smart contracts. Identity verification. To ensure trust and security, you can integrate identity verification server that validate both driver, passenger, and to involve KYC, know your customer precisely. Now I will be explaining a requirement based on the technology we have used. So for hardware requirements, we will be using server infrastructure. In that, we'll be using web servers and blockchain nodes. So like basically, blockchain nodes will bring the blockchain technology concept in our project, which is carpooling. Database servers, storage, mobile devices, GPS, and geolocation devices. So database servers are like which will be connecting the uh, data of the like information of the driver as well as the payment gateways. Storage will be uh, the database will be obtaining the data from the stored information which are stored in decentralized storage system and mobile devices. So mobile devices are the mode to operate between the clients and the drivers, or you can say the system. GPS and geolocations of the devices can be enabled to share the location of the client to the driver for the service to start. Now the software requirements. So software requirements are a blockchain platform, smart contracts, oracles, mobile app developments. So these are the software requirements which are used in the carpooling system to manage and mobile app development is necessary because uh, there are usually bugs caught while the development of the system. So for eradication of the bugs, we need mobile app development uh, software. And
Now, coming to the national status of car sharing in India, car sharing primarily operates through platforms like Ola. Ola offers various transportation options like taxis, auto rickshaws, and shared rides. Here's an example of how car sharing works in India. The first thing is mobile app. Ola operates primarily through its mobile application, which is available on iOS devices as well as Android devices. Users need to download the app and access it by creating an account. Next comes booking a ride. The user opens the Ola app and specifies a destination. The app then provides options for available rides like Ola Micro, Mini, Prime, and others. The user chooses the type of vehicle they prefer. The next comes driver matching. Once a ride type is selected, the app matches the user with the nearest available driver. The user can see the details of the driver like the name, photo, and vehicle. Now coming to the international status of car sharing operates internationally with platforms like Uber being a prime example. Here's how car sharing works typically internationally using Uber. The first comes ride request. The user opens the Uber app and enters their destination. The app then displays the available ride options like Uber X, Uber Pool, and Uber Black. Next is environmental initiatives. Uber has launched initiatives like Uber Pool to promote carpooling and reduce the environmental impact of individual rides. Confirmation. The user confirms the booking and the driver is alerted. The user can track the driver's location as they approach the pickup point. The last point is expansion. Uber operates in numerous countries and cities worldwide, making it accessible to a global user base. So to conclude this PPT, in this study, blockchain technology can be used to revolutionize carpooling by eliminating the need for intermediaries, enhancing the trust, reducing cost, and improves the user experience. There are a lot of challenges like adoption rates, scalability, and regulatory compliance, but still, blockchain-based carpooling holds potential to make it an exciting area for future innovation and development. Here are some few references with the help of which we have used to make this PPT. Thank you for watching this video.